Good morning, everybody. We are the Milan team, which consists of Dorian Garro, Ahmed Karim, and Matteo Valentino. Firstly, we decided to make this video in order to give an account of what we have made during this exciting experience offered by Fraunhofer, and we are pleased to show you our project. The experience started on October 7th, 2019, when we landed at Bremen, not so easily for some problems with the airplanes and stuff like that. And finally we could take part of the project. In Germany we had the opportunity to learn a lot about composite materials, specifically about fibers, their properties and their environmental impact. We also learned how to test the different mechanical properties of several fibers through the tensile test and the bending test. Finally, in the labs of the building we developed a little prototype, which was a tablet built as a sandwich material. We also compared different tablets each other in order to choose the cheapest, the most resistant, and the most environmentally friendly and the lightest. After learning all the useful techniques to analyze different fiber and materials that we used during this little competition, Fraunhofer assigned us a task. The request was to develop and test a clipboard made of sustainable fiber composites, and the objective was to reduce the use of primary fossil raw materials by using bio-based or recycled materials while using the advantageous effects of fiber composites. In order to achieve the assigned goals, we had to organize our team, which means that we needed different roles, so we decided to split the work like this. Dorian Garro is the team leader, so he deals with the external contact person. Karim Ahmed is the IT representative, so he dealt with digital data and formatting. Matteo Valentino is at the same time the secretary and the time manager. Sergio is the conflict manager, so he cared for a good climate. We met several times at the school during this year, where we wrote down some ideas by using the brainstorming technique. At the end of the meetings, we concluded that for core materials we could use chipboard, cardboard, pressed cardboard and Tetra Pak from cans. For fibers, we suggested fibers like sisal, coir, jute, carob and flax. For resin, we could use possibly natural resin, like glues made up of bone meal from industrial waste. The first step we made after the brainstorming was focusing on fibers. We found a bunch of digital data on fibers, and we have been based on price, mechanical properties, and sustainability in order to choose the best one. We noticed that the price of sisal was not so high. It was actually 21% of the price of grass fiber, and it has good mechanical properties such as the tensile strengths, and it's between 468 and 460 megapascal, and the Young's modulus it was between 9.4 and 22 gigapascal. After that, as I said before, we thought about 4 types of cores: chipboard, pressed cardboard, and Tetra Pak. Finally, we chose chipboard because it seems to be the most resistant. It was sustainable because it was made from industrial waste. As regards the resin, we decided to use the epoxy resin while waiting for a more sustainable one. After that, we got the samples. We noticed that chipboard was too heavy for its purpose, so we changed the core, always keeping the same fiber, which is recycled cardboard, which is way more light and sustainable because it also comes from industrial waste. And we used epoxy resin because we didn't find another cheaper and more sustainable one. During the material search, we weren't able to find a resin that satisfied our needs, so we stuck to the same resin. As for the fiber, we weren't able to have contacts with the company that could provide us some sisal fiber, so we sadly had to use another placeholder as the fiber, which is jute fiber. Once we got all the materials, we started testing and we assembled a first prototype in our school lab, built with a cardboard core, a jute fiber and a polycrystalline resin. We did several tests to better understand how to build the sandwich structure, but we also tested how much the fibers were needed. We were surprised by the results because only with these materials the cardboard was much stiffer and also lighter. This made us think we were on a good path. Sadly, the week after our prototype was built, we went to the school trip and the following day the government declared a total lockdown due to the coronavirus outbreak. Obviously, the prototype and our whole research was at school, and we couldn't get it back until the start of the new academic year. And all our informations are obtained by thoughts and deductions due to the fact that we hadn't any test results. Finally, to conclude this video, we have to thank everyone for the chance that we had in Germany, and we hope everything will turn out great and to move on from this crisis. Thank you.